Work. So we have this as a function. And we're looking to find its inverse. So there's a few steps for this. First of all, I won't use fx. I'll use y. And I'll swap x and y. Need those arrows, but I'm changing x and y to. So I'm now looking to find everything in terms of y. So solving for y. I have an idea there's going to be a -1 somewhere in it. So I'm going to subtract 1 from both sides. I just want y on its own. So I have x minus 1 is equal to 2y cubed. Matthew? All right, I don't want 2y cubed. In fact, I don't want 2 or the cube, but I got to get rid of them step by step. So I'll divide by 2 first to get rid of the 2. It's a good idea. Because 2 into 2 goes once. And now I have this x minus 1 divided by 2 is equal to y cubed. Now I don't want y cubed, I just want y. So the opposite is, Sam? Yeah, the cube root of this side and the cube root of that side. Well, luckily enough, the cube root cancels perfectly with the cube. And y just equals the cube root of x minus 1 over 2. The finish line, f minus 1 of x, cube root x minus 1, 2. So I just rewrote it with this terminology. Now that's really difficult to do in one step without showing any work. So if you manage to do it without showing work, that's amazing. And unbelievable. Okay. Question 2 then, which wasn't part of homework, but we will look at briefly. Find the inverse of these functions. So we've got 2 functions. Look pretty simple. They are, I think. 8 minus x is 1. And fx is 9 divided by x. Let's do the inverse of this one first. So y is equal to 8 minus x. So x is equal to 8 minus y. When I swap the variables, solve then for y. So I'm going to subtract the 8 from both sides. It's a good step to get rid of that 8. So if x minus 8 equals minus y. I don't want minus y, I want positive y. So everything needs to change signs here if I want positive y. Y is equal to negative x plus 8, which I can write 8 minus x as well. It's equal to y. And then final line, f inverse is equal to 8 minus x. Now, maybe you notice that that is the inverse of that. Second one, fx, so y is equal to 9 over x. Swap the variables, x is equal to 9 over y. Solve for y now. So you've got to multiply both sides by y. So I get xy is equal to 9. And then I need y equals, so divide both sides by x. And y is equal to 9 over x. And final line, f inverse is equal to 9 over x. Okay. Shield. What do you observe about your answers?
They are the same.
Yes. The inverse is the same as the original function, which is mildly interesting. Burgundy, no headphones. Anyone else with headphones for them? You can use them maybe when you're doing classwork, but not for that. Yes.
Does it only work because one of the outputs of the same stuff?
All the ones in question 1 are different. These 2 are just some functions are their own inverse. And something we'll get onto a little bit later, but I'll briefly explain when I find it. Is that you can do an inverse of a function graphically. So let's say we have some function. Let's see this, yeah. Have some function. It's a quadratic one. The inverse of that is its reflection in a certain line. It's a reflection in. Let's do it. Different color. It's the reflection in this line. That is the line. Does anyone know the name of that diagonal, perfect diagonal line through the center? It goes through the points 1, 1, 2, 2, 3, 3, 4, 4, and so on. No. That's the line y equal to x, or x equal to y. It's called that. It's its reflection in that line, where all the y's equal the x, and the x and the y, so you're swapping x's and y's. It's the reflection in that line. So if you wanted to do that, and we'll do that later on in the unit. This is going to look totally different. If this started to look at itself in the mirror, in that mirror, you'd notice that this point would shift to here, point here, shift to there. So it's not going to be the same anyway. I know that for sure if it's looking at itself in the mirror. But for these ones, if it looked at itself in the mirror, it would look exactly the same. We'll get into that, what they would look like. So maybe its reflection is on the mirror in some way, and then therefore it looks the same. We won't worry about that too much at the moment. All we need to do is notice that some function's inverse is exactly the same as itself. That's kind of interesting. Maybe not majorly. Okay, so a major topic in functions is these U-shaped functions, quadratics. They take up a lot of the thought on functions. And we've done some quadratics, we've done solving and factorizing quadratics, and now those numbers will start to mean something graphically. Well, let's just remind ourselves how to solve, factorize quadratics. So I'll do these. So there's a few types we need to look at. First example, x squared is equal to 3x. If you're trying to solve or factorize something, make sure all terms are on one side. So these are terms on opposite sides. Bring everything, that's also blue. Bring everything to one side, so subtract 3x from both sides, and you get this. That'd be the first step. Now the problem with this quadratic is it's missing a third term. And it's missing a third term. So this one is just a highest common factor out of it will only have one bracket. Now we did this in the last unit, so this should be a revision. Common factor of both these is just x. What's left behind? X minus 3. Okay, that's not news to you. What's the answer then? What's the solutions to this? There's two. We let each bit separately equal 0. We did this once again in the last unit. That's called the Null Factor Law. Two things multiply to give 0. They must be both separately equal to 0. So x is 0 from this, and x is equal to 3 from this. If I add 3 to both sides, x must be 3. So that's the highest common factor method if there's only two terms. So the key here is there was only two terms, two x terms. So they have highest common factor. One method that I haven't put there, and a lot of you seem to not remember when it comes to the exam, is the difference of two squares. So maybe I'll put a second example here. Difference of two squares. So it would look like, so you have to solve this. X squared minus 81 is equal to 0. There's a couple of ways of solving this, but you can solve this using factorizing. You have to be able to factorize this. What's the factors for this? This time I don't have the middle term. There's no x middle terms. There's no common factor to both. So I can't use this method. There's no x in both to take out. Alicia? Squared? Square root? You could, but I want to factorize it. Okay?
With these, this x plus 9, I know the.
That is an answer, yes. Is that the, yeah, so this is, if you notice that this term is a square number, and it's minus, that's why it's the difference minus of two squares. That's a square, and that's also a square number. It can be factorized into x plus 9, x minus 9. It can also be solved a lot quicker by just adding 81 to both sides, and x squared is 81, so x is the square root of 81. But if I need to factorize it, this is the factors. And also here, x plus 9 equals 0, x minus 9 equals 0, and x is equal to minus 9, and x is equal to positive 9. So you get the plus and minus 9 in the end anyway.
So your answer would be x equals -9.
And yes, two answers. Quadratics usually have two answers.
Usually, you couldn't just like figure it out in your head.
Yeah, as I said, yes, you could, but if you're asked to factorize, it's good to have that in your arsenal. A lot of you didn't know how to do that, and Victor in the exam, there's one question with t's in it, and you didn't know how to factorize. It was 9 and t squared. It was t squared and 9. T squared minus 9. You didn't recognize 9 as a square number. Therefore, it didn't factorize and didn't get it right. The rest of them should be straightforward. If there's 3 terms, and the 2 more examples that I'll do, or I'll do 3 more examples. These next 2 examples are very similar, so I'll just put them both up. I've got x squared plus 3x equals 28, and 5x squared is equal to 3x plus 2. Now, if you think you can do these faster than me, you should be able to do them in the last unit. Try and do them faster. I'm going to run this out slowly. So try and beat me on these. You should be able to do them faster. Or just okay. So this is what should be standard quadratics at this stage. The only problem is that this one doesn't equal 0 at the moment. So if I subtract 28 from both sides, I get equals 0. Now I can factorize. For quadratics, you always should be thinking factorize. Those 2 brackets that you open in order to solve. There's no common factor between all 3, so I can't take out a common factor. I need these 2 brackets in order to factorize. And then I go through my processes. A few of you have different methods of doing this. For me, I just look at what multiplies to give x squared, and that goes here and here. That's x times x. And then I think about what multiplies to give 28. And I know a number of things, 1 and 28. I have 2 and 14. I have 4 and 7. And I reckon because they need to be added or subtracted to give in the middle term, 4 and 7 is going to be a winner because 3x got from that. 4, 7. And you think about my signs now, and this is what I do for the signs. 4 times x is 4x. 7 times x is 7x. I need to make this positive 3x with those 2 multiplications. So plus 7 minus 4 makes a positive 3. So this multiplication must be plus with the 7. This must be minus. If you're asked to factorize just, that is as much as you need to do, but we will always be asked to solve now. I let each bracket separately equal 0. x is now 4 here. One answer. X is -7. Answer number 2. Does anyone know graphically what those answers mean? They're on a graph. Where do they sit in the graph? No. Okay. They do mean something. This second example is harder. Has anyone done the second one? Maybe you've done the second one. What do you get, Gabe?
Not the right. That's what I'm zero on the right.
Okay. So -3x minus 2 is equal to 0, and then you open your brackets, yeah?
Yeah. And 5, 2.
So you put 2 in this one and 1 here.
Yeah.
2. Okay, and then you look. That's 2x. That's 5x. I need to make -3x. I don't know if you did this, but that has to be minus. This has to be minus.
Yeah.
This one has to be plus. So it's 5x plus 2. They both equal 0, so both separately would equal 0. So this is the final step. You've got to get used to doing this. X minus 1 is equal to 0. In this case, this is pretty easy. This is just 1. 1 take 1 away, 1 equals 0. This one, 5x is equal to -2, isn't it? If I subtract 2 from both sides, divide by 5, both sides, and I get -2/5. Second answer. Do the last one as well, Gabe?
No.
Go on, I'm going to do the last one now. So the first type was if there's only 2 terms and equals 0, you just highest common factor out. This one is not one of those. Second type was difference of 2 squares. Watch out for that. Third type, these would be standard. Just make sure everything's on the same side and it equals 0. And fourth type is the other one on the board, which I'll do now. It's perhaps with some fractions in it leading to a quadratic, which it doesn't look like a quadratic just yet, this one. So there's some fractions. Some of us were not amazing at this in the exam. Some of us were. So if there's fractions, I need a common denominator. A common denominator is what?
X squared plus
X squared plus x, yes. Common denominator would be x times x plus 1, which you could write as x squared plus x. But it is these two multiplied, which means this one doesn't have an x plus 1 at the bottom, so it needs to be multiplied by x plus 1 at the top. Now, I'm not going to write the denominator if I'm trying to solve. They all have the same denominator. I'm trying to solve it. Now, you don't need to have the denominator in the answer, because you're only looking at the top of the fractions. For instance, the same as if I know 2 over 7 is equal to x over 7, x is equal to 2. I don't really, once they have the same denominator, it doesn't matter anymore. Sam?
-1.
Well, you can write over 1 here in the question, yeah? But I haven't got that far yet. That's this -1 multiplied by x. Then this -1 at the end has to be multiplied by both, because it's missing both denominators. So it's again, that was in the last unit, so if you didn't follow. Now, I haven't put in the denominators for this reason. They're all the same. I'm only caring about solving the x part on top. Okay, so multiply out 4x plus 4 minus x is equal to. Now, I think this x squared plus x is this bit, and must be minus x squared minus x when I multiply it out. Quick rearrange, bring everything to one side and add and subtract like terms. I think adding x squared to both sides, adding x, these are these two added over 4x plus 4 minus x is equal to 0. So let everything equal 0 if you're trying to solve. these quadratics. I think these two x's cancel. I'm left with x squared plus 4x plus 4 is equal to 0. Gabe, what did you get for the answer? Factorize x and x squared. Numbers to multiply to give 4, and we'll add to 4. That's 2 and 2. They've both got to be plus. I don't even need to check because I can already see that they both have to be plus. That's plus 2 makes the 4 in the middle. What's my answers? It's just -2. They both give -2. X is -2. So there's only one solution to this. From both those brackets, x -2. Doing the same process. This I just ran out of space. Let them both equal 0 separately. Okay, that's still solving quadratics. We haven't talked about the graphs of the quadratics yet. We just need to have that skill, solving and factorizing quadratics. Let's do a Kahoot now to test you out in that.